Okay, looks like recording has started. Oh, Daniel Jones was saying that he was working in the middle of an essay, but luckily saved it right before it started happening. Yeah, my wife came into my office and says, "It's pretty windy out there. You may want to stop working on your computer." So I did, and we did lose power shortly after that. So anyway, here's our devotional for today. It's Romans 7:18-20. For I know that nothing good dwells in me, that is in my flesh. For I have the desire to do what is right, but not the ability to carry it out. For I do not do the good I want, but the evil I do not want is what I keep on doing. Now, if I do what I do not want, it is no longer I who do it, but sin that dwells within me. And so this is important to remember for Easter, because we know that it was Jesus' sacrifice on the cross that has saved us, not ourselves, and that our flesh and blood definitely takes us to do things that we know we shouldn't do. Any comments? All right, moving on. So due tonight is your design document. Is due by midnight tonight, and then the chapter 9 quiz on implementation. So I'm hoping that should be quite easy now that you're taking it from home at your leisure, and it is open book and open note. Again, no web access, no use of the web, but your notes and your textbook. So I'm thinking that that would reduce the amount of study times. You could just quickly brush up on the chapter and then take the quiz. And since you can refer to your text, I'm hoping that it's a less of a time draw on you to take the quizzes. And then Friday, April 17th is the chapter 10 and 11 quiz. Now, it was originally scheduled for Wednesday, but I moved it back to Friday to give you some extra time. And then the chapter 12 quiz that on the chapter we just covered, software support and maintenance, is on Monday, April 20th. So any questions about things coming up?
Has the access code been removed for the chapter 12 quiz? Because when I checked it a day or two ago, I still had one.
Okay. I do not know the answer, but I will make sure that the password has been taken off and you have clear access to it.
All right. Thank you.
Yep. Any other questions? Okay, let's write that down just so I don't forget.
Will the design document be similar to the requirement specification in that if you're not entirely content with our first submission, then we'll have the opportunity to do more afterward?
Yes, absolutely. You can keep resubmitting the software design document as many times as your team would like to for additional points. No penalty. Yep. Again,
thank you.
Yes. So again, what I'm primarily looking at is, little intro with, your acronyms and things like that, just like you had in your requirements. So the little preface and that. But the main crux of the software design document will be your UML case class diagram and any state diagrams or sequence diagrams or other UML diagrams that you think is needed to illustrate what your design is, and then text that describes the diagram so that it's easily understandable by someone looking at the diagram and with the text description. So that's primarily what I'm looking for. Okay, so moving on. So as promised, we are doing a midterm review, and we went through the other questions, the essay questions, but this is a review of the design problem at the end, chapter number 11, and it was the hardest question. It was a question stolen, or more appropriately borrowed with permission from Dr. Boss. So that was one of Dr. Boss's questions that I have borrowed and really like. It is, in my mind, a stretch question. It is more difficult and makes you require your knowledge in more in-depth way, because the problem was not as simple as either the examples in lecture or class, or your text. Sorry, your text. The one design problem that you submitted a design was a little bit more complicated, but not nearly as complicated as the problem that presented. I would say the amount of work was about the same, but there was some complexity in there in terms of the interactions of how things interact that made it a difficult problem. So if you did struggle with it, that's to be understood, because it was a difficult problem. So partial credit was given on the midterm for at least if you were headed down the right path and you're showing your knowledge of UML diagramming. And in particular, it was a UML state diagram. So I didn't actually ask for the class diagram, but you'll see a lot of students actually went through the process of having separate classes, and so they could have easily done a class diagram, but for the midterm, only a state diagram was required. There's another component to the problem that no one actually quite noticed, and that was that there was some ambiguity in the requirements. No points were deducted for not realizing there was ambiguities and stating this is the assumption I made, because I could tell what assumption you made by looking at your solution. But I do give bonus points for any student that recognized that there was some ambiguity. And in particular, there was not stated in the problem whether when you clicked on the switch, on the button switch, whether the temperature is automatically read or not. It could be that it was only on every 15 seconds and such. So you could get some transitory states added into your problem depending on what assumptions you made. So a lot of you made assumptions, and that's fine. But there is extra credit available if you noted that there was actually some ambiguity in the way that problems was stated. I don't know if Dr. Boss intentionally meant to have ambiguity in question, but I like the fact that there is a little bit of ambiguity in the question, so that you have to wrestle with that a little bit, because that's the real world. There is ambiguity in the world. Everything is not clear cut and laid out for you. There are a lot of places where you have to fill in the gaps, and hopefully you fill in the gaps by asking your users. So let's take a look at some possible solutions. My caveats here are, please remember there are not any right answers. There's multiple ways to address a problem and to design a system. So there are no right answers. And consider this a design review. I actually have errors in my design. If you can find them, please point them out. I don't necessarily, it was long enough ago that I actually created the solutions. I created the solutions actually before the spring break. So it's been a while that I looked at it, but I do know that there are some issues with these these state machine solutions that I am presenting. So here you can see in the lower left corner, the assumption is the temperature is only checked when the software timer goes off and not when the button is pressed. So that's how we get this transitory state. And we can see here that on is less than or equal to 50 degrees, blue is less than or equal to 50 degrees, and off is greater than 50 degrees, and red is greater than 50 degrees. When I state above, I'm saying that it's above 50 degrees C on a timer transition, on a timer tick, and then when it's below, the event below means that it's moving to 50 degrees C or below on the timer tick, and then we push is a push of the button. So that's my definition of the terms that I used in the diagram, just to shorten the diagram, the actual wordage on the diagram. I gave a little legend of what each of those mean. So we have 3 states here. I have the switch is on and the blue LED is on. We have the switch is off and the red LED is on. And then we have a state which is the switch is off and the blue LED is on. This is the transitory state I was talking about that could happen if you push the button and the timer hasn't gone off yet to check the temperature, that you could end up in the state that the switch is off and the LED is on, blue LED is on. So starting off in, let's say we're in the switch on and blue LED state, blue LED on state. On entry into that state, and I didn't actually grade heavily on having the activities in the state diagram, but the switch would be turned on and the LED would be turned to blue. And that's pretty evident by the state and pretty obvious, but I actually just went ahead and put in the actions. So what happens if the temperature, the timer goes off and it says it's below? If it's below temperature, it continues to stay in the switch on state with the LED blue. But however, if the timer goes off and the temperature is above 50 degrees C, the switch will turn off and the LED will turn red. So we end up in the switch off and red LED on state, and on entry into that state, the switch is turned off and the LED is turned to red. So that's pretty obvious. Now going back to the switch on and blue LED on state at the top, if you push the button, you go to the switch off and blue LED on state. Again, the actions are pretty obvious there. And if you push the button again, it will go back to the switch on and blue LED on state. So you can see there, you can go back and forth between on and off with the blue LED on. In the switch off and red LED on state, if it drops below, we go to the switch off and blue LED on state, because again, the LED color will change, but the switch position doesn't need to change, and it, by the specification, it doesn't change. And in the switch off and blue LED on state, if it's above, again, you switch to the switch off and red LED on state. Being complete, I have the push button state. If you push the button and you're in the switch off and red LED on state, you don't go to the next state, you stay there. And if it's above, you again stay in the switch off red LED on state. So any questions about that, or any comments or any observations?
So in this case, each action between states is either timer or event driven?
Yes. Well, actually, I would consider them both events. So the timer
Well,
clicks.
timer event, but
Yeah, the timer event,
physical event versus timer.
and then the physical event of pushing the button. Yes, are both events.
Okay.
Does that answer what you're asking, or were you asking something different?
No, that's it. I was just confused. The main thing that I was not sure on the question was how to handle the timer. Just like it's not really its own state, so I wasn't entirely sure how to do that. So I mostly just assumed that it's an actively updating check,
Right.
rather than time-based.
And Jason, that's a good observation. So what is the assumption here with the timer? The assumption is it's either part of the system that generates an event and there's something generating the event, probably another class, or there's some external system that's generating that event. So that is an assumption that's being used here. Is there something that's triggering these events to happen on the periodic basis?
Okay.
Yes. So that is correct. There is this inherent thing that there is this timer event being generated on the periodic, what was it, 15-second basis? Something like that. I don't know.
Is there supposed to be a start state?
There could be a start state, but did the problem state what state the system started in?
Not that I remember.
I don't remember one either. You could certainly say, okay, that the default state is switch off, blue LED on, but there was nothing to state that was the case. So that would be an area of clarification that you'd probably want to ask your customer. Hey, if this system is first fired up and initiated, where do you start? So yeah, I didn't see a description of what the initial state was. And the other thing is, I didn't see anything about an exit state, so I assumed there wasn't an exit state. But again, that was an assumption. There isn't any description of how you would actually leave this particular state machine. So going on to another possible solution, here the assumption in the lower left corner is the temperature is checked when the software timer goes off and when the button is pressed, but only for on or off. So here we can see that instead of 3 states, I've got 4 states. Again, the same description of the problem with the on less than 50, blue is less than 50, off is greater than 50, red is greater than 50. And then the definitions above and below. We have push above, which is push the button with the temperature above, and push below with the button with the temperature below or equal to 50. So now I have a push above and a push below. That is the assumption here is that the temperature is taken as soon as we press the button. So the resultant state machine that I came up with looks like this. I can definitely see there's some errors in this diagram myself, I think. So let's go through it. So the switch on blue LED on state, again, has all these actions. They're pretty self-explanatory. If the temperature is below, we still stay on the on and LED on, switch on and LED on state. We push, well, let's see, let's do the above. And we do the above, and we notice that there's a transition if the temperature goes above to switch off and LED on, which was the same as the diagram above. So right away, I'm seeing, gosh, something looks wrong here. So does anyone see some issue with this diagram here? In this particular place I'm describing? So notice this below transition that goes to switch off blue LED on, and
it does not appear to be capturing your mouse Maybe try turning on, what is it, PowerPoint's laser pointer thing.
So do you
Oh, now
see?
it's there.
There's yeah. So okay, so that's a good point. I wasn't using the mouse was my problem. So here's the transition I'm talking about. If the temperature is above the 50, it goes transitions from switch on blue LED on to apparently switch off red LED on, which is what I read. But gee, there's this weird arrow that comes below here, which was meant to be an arrow from here to here. But obviously there was an error in my drawing tool, and that's not clear. So if we were a design review meeting, I would tell to the scribe or the person taking meeting minutes, this diagram needs to be cleaned up because these states, we got the arrows and lines on top of each other, and I know what the right answer is, but certainly it's not correctly drawn as it is. And then the push above and push below will switch you to switch off and blue LED on, because in either of those states, the switch will go off and the blue LED will stay on. And then we have push when you're push from above, that stays in the same split state, and if the temperature is above, it switches to off and the LED on in the switch off blue LEDs. So you can go through all these different transitions and see where the things are. But again, there was a hidden assumption that was made in this problem. So note that I have recorded on here two variables, the permutations of two variables, the switch position and the color of the light, as being the states. So anyway, any questions? I know that this is the first time you've seen it, so it's sometimes hard to see any questions or anything. But if you have any other questions, let me know and I could try to answer them. But this is another possible solution.
Were you intending on giving like specific comments on any like on each of our submissions, or was that ever a part of your plan, or were you just planning on just giving us the grade and then just hoping that we knew what we did wrong? Because like I know what my grade is, but I don't really know why what I got subtracted on.
Yeah. Please send me an email and I'll make sure. I was trying to put comments down for all of them, but I know that if I don't click the right button that says update something or other, that when I go on to the next question or if I go to the next student, those comments may get lost. So please send me an email that says that you want comments on whichever problems you want comments on. I mean, whatever questions on the midterm you want comments on, and I will fill that in with more information. I thought I had put down comments on each problem that I took points off from, but was not foolproof. So yeah, send me an email, Gabriel and Gabe, and I will try to add comments.
Okay, sounds good. Thanks.
Yeah. So another possible solution is this. So what did I do here? I divided this up into 3 classes. And Jason had the comment about the timer tick. And look, lo and behold, I've added the timer in as a separate state machine in itself, representing its representation as a class. So that is sort of where Jason was going, I think, with his question, or might have been going with his question. And we can see here that the transition of the states are quite simple, that there's just 2 states for each of these particular classes, but you do have a bunch of events that happen. So we have the switch off and on states. And then if the switch is below temperature and you're off, you can go up to on. And then if you push and the temperature is above or below, it will take you to the switch off position. If the temperature is above, it'll take you straight down to switch off. Below and above in the switch off position makes no change with regard to the switch position. And then below loops you back in the switch on position. And then with the color, again, the events above and below representing here. And then we can see here that I have this timer, and the timer event goes off. And when it's greater than 50 degrees, that's when I send the above in for the above 50 degrees state. And then when the timer is less than 50 degrees Celsius, tends you to this less than or equal to 50 degrees Celsius event, and it sends you to the then it causes the send below event. So that's where the below and above actions actually get transmitted. To be more complete here, I'd probably have a button that generates the push above and push below. Again, push above and push below seems to imply that when you push the button that it's actually taking the temperature as well. So that's sort of an assumption that you can see that's in this particular state diagram. So any questions or comments about this possible solution? So again, we broke it up into multiple classes rather than trying to shoehorn everything into one Uber class or a class that was doing multiple things, and we divided up into separate classes. So another very different solution. So the one thing that was really interesting and was Jonathan Dyke's submission for this problem. And he actually came up with this solution where he had two major states switched on allowed and switched on not allowed, which was dependent on the temperature. And then he had substates within those major states. And Jonathan, so I did mention this is basically a hierarchical state machine. It's probably drawn a little bit differently than I would have drawn it, but it does convey the information that this is a hierarchical state machine. Have you worked with, Jonathan, have you worked with hierarchical state machines before, or did you just get this from the comment that I made about state diagrams that hierarchical state machines did exist and how they work?
I saw a diagram of one, I think, in the book. This is also not how I would have drawn it, but I didn't know how to draw
do it in the tool you were using. Yes.
Right.
And again, your midterm was a little bit more difficult, or it could have been more difficult in that most of you were using drawing tools rather than just hand drawing it, which in class, everyone's just hand drawing it. So you're fighting with the tool and how to get it. But yes, typically you would actually, oops, went to the next slide. Typically you would have a big box where the switch on allowed state is right here, and then the substates would be actually contained within the state. And so here we can see that the temperature less than or equal to 50 degrees and the temperature greater than 50 degrees automatically just takes you to these major states. So actually these states here of the temperature greater than 50 and temperature less than 50 could just point to the individual box, and then you would actually have one of the states, in this case, switch off would be your initial state for the substates in the switch on allowed state. And then you just have the button on and off press things, but basically the temperatures are all handled by these major major states right here, and then the substates are really mostly dependent on the button press. It's not, the temperature is only going from the major to the minor. And the nice thing is that there are a lot of frameworks and tools for creating state machines in your code without you have to explicitly code it out, that there is a tool that you specify these states that you created in your diagram and laid out what actions happen, which correspond to pointing to a method, and also what transitions transition you from one state to the other. And a lot of tools will actually have this notion of substates, of a big state that consists of substates, and what the initial state is. One particular place that this is particularly useful for is if you have a complicated workflow in your user interface, and users click on things. You have some error condition that pops up, like, I don't know, you run out of memory, or internet connectivity is lost, or whatever the case may be, or temperature raises above a certain limit at this point. You could actually transition to another screen, and a state machine is a great way to model and implement your workflow through your user interface. So that is a valuable usage of that. And typically you will get substates in a workflow state machine, because you do have situations where things happen. So what does the unlabeled arrow above switch on do?
The one connecting switch on to substate, I think.
Oh, so yeah, that is just linking to the substates, right? That's not actually a transition. The transitions would be these temperature moves. So, Jonathan can correct me if I'm wrong, but that's just illustrating that in his diagramming that these substates correspond to this major state. It's just a line that connects them instead of putting them actually in the bubble, because I'm assuming that he had difficulty in the tool putting bubbles inside of the big bubble.
I was trying to stay within the time frame of the midterm.
Yeah. So that's the other thing is when you're using a drawing tool, at least for me, it does take longer and it is more work. So that's why I was suggesting if you want to hand draw it, you could just take a picture of it and submit it. So that was an extra application. Yes.
That question was for the previous picture, not for this one.
Oh, okay. Let's do that. Okay, so for this diagram here, Ian, is that?
Yes.
Okay.
Yeah.
So what is the unlabeled arrow above switch on to?
Yeah, there are two labels at switch on that go up. One of them is unlabeled.
Yes, that's a good point. So that may be, well, certainly that's an error, a diagramming error at the very least. So if we go to process of elimination, we have below and above, and then we have push above and push below. I don't see any event that would correspond to. It looks like it's just an extraneous transition that I created and then ended up not having. It's interesting that it goes over the below button, and that would be the only event I can see that would put us back into that state.
My assumption was it was an extra transition made for a second below, just by accident, but I figured I'd ask.
Yeah, that could be the case. At this point, I can't really tell you what that arrow was meant to be because I don't see anything obvious. Yeah, because if you're push and you're above the temperature, you would go just to switch off, and you push and you're below the temperature, you would also just go to switch off. And the above is obvious, and below, yeah. It's an extra link that I have no idea what that event corresponds to. It's definitely an error. Good. All right. So that is a review of the midterm. Again, if you have questions about this question or any of the other questions in terms of how I graded it and such, or just in general, please send me a message and I will send me an email and I will look at it. So let's bring up, I'm going to bring up the student list. So I'll let you see that here. And let's grab someone from the boomerang team. We did the battery team before. So let's say Micah, how's the project going for the boomerang project? Let's see if he's even here today. Yeah, he is. So Micah, how's the boomerang project going? What can you tell me in terms of the status update on where the project is? Either microphone or chat is fine too. So Micah says it's going well. Good. Can you elaborate on that more? It's going well. Sorry, he said it's going well. Can you elaborate on that more? Okay, he's prepping some material real quick here. I think I'm deciding that's probably even more challenging when we're online to do the elevator pitch. So how about anyone else for the boomerang? You're welcome to chime in while we're waiting for Micah to present. I'm assuming he's getting ready to try to present something. Can anyone else from the boomerang project fill us in on where you guys are at? So for instance, did you guys work over the Easter weekend, or did you take the Easter weekend off?
Hi, this is Marshall.
Hi, Marshall.
No, we're going well. We have a scheduled meeting time Tuesdays and Thursdays.
Right. Okay.
And so we've been working them. We did not work over Easter.
Okay.
Yeah, that we just kind of slipped our minds. We didn't really get much done with it, but we will be. We have a work time every Tuesday and Thursday, so we get a lot of stuff done during that time. We usually work on the assignment that's due. We talk about what we need to get done, what we need to look at.
Right.
One issue that we've had is we've kind of hit a couple of roadblocks with requirements and other things like that. We're trying to get in contact with the client who first proposed this project, because we need to talk to him about some stuff. So that's kind of one major thing that we're trying to get done right now, so we can continue working on how he wants it to look and stuff like that.
Right, and that's one extra area of difficulty that you have over the other project teams, and that you actually do have a client. So that is add some extra. So are there and then so Micah chimed in here on the chat. We are planning our next steps after finished viewing our current steps. Our next step is to share with the client what we are working on and making sure is what he wants. So is that a presentation or something less formal, Micah? Less formal. Okay. So it's not actually a presentation that you put together. Okay. And so are there any areas of risk? I'll open this up to everyone on the Boomerang project. Are there any areas of particular risk that you're concerned about in terms of how can we solve this problem, or what actually do we need here?
For risk, do you mean places that we think that we'll have trouble with? Or
yes, exactly.
Okay, I think for me, I think the biggest trouble is getting in contact with our client, and then needing to scale things down a bit.
Right.
I think that's our biggest thing. In one of our meetings, we had talked about how we think we might have overscaled it, trying to think big picture.
The scope is too
our
big,
scope
yes.
was too big, and we were trying to think big picture first, but as of right now, I think we're trying to just kind of scale it back so it's specific to the client and what he wants, because that's our main focus right now. We were trying to make it more universal, but I think as of right now, we're needing to focus on just the client based. But the issue that we're running into is needing to get in touch with our client and talk with him about our specifications and requirements that he wants. We have some, but we want to double check with what they want, what Mr. Faber, our client, what he wants, and just double check that all the requirements that we have are in fact correct and stuff. So that's probably the biggest thing that is our stopping point right now, is that we're trying to get in touch with our client, and it's kind of a one-way street right now. We will probably be sending him another email tomorrow to ask him if he can meet later this week.
But also can be difficult. Yes, trying to get time with your client is a common problem. Yes. So we had someone else chiming in.
Yeah. This is Michael. The formulas are really hard to, like, not necessarily understand. Like, we understand them, but it's the units that we can't figure out which units are used to figure out which formulas to use in the actual project itself. So that's a road bump that we have.
Right, and that's very important because if you're not properly checking the values and their units to be corresponding right, you could give vastly different and incorrect answers, and that's a common issue. So in terms of scoping the problem and de-scoping the problem, so Spencer, what approach would be a good way to handle the scoping problem? Pointing to software engineering, one material, there's some obvious things that you can do, and what other things, and maybe you have other things you're planning on doing in terms of descoping the problem with the input from your customer.
Yeah, I think one of the things, like we've already discussed, is I think we're trying to do too much, like broad, and so I think if we kind of like break it down into like smaller subsections to see what's actually going to be able to be finished by the end of the semester is like the best way for us to actually descope this thing.
Right. So what kind of list? Maybe a priority list might be a good thing to work on with your customer. What are some of the features that have the highest priority?
Yeah, I think that's actually a really good idea. We should probably do that.
Now, certainly you can't just go by priority alone because certain features go with other features. So if there's a really important feature that depends on a lesser important priority feature, you can't necessarily sever it, but a priority list would be a great start, right?
Mm-hmm.
So has your team, or is your team dealing with a database at all?
I think we were talking about using one, but currently we don't have one set up.
Right. Has the team looked at a schema, database schema?
No.
Oh, I know Nathan was working on that.
Okay.
I'm not too sure if he's in class right now.
Okay.
But he was working on that a lot with figuring out the database and how we're going to put everything into the database.
Yeah, and that would be important for you to not lose sight of because your database and particular the database schema, how you're going to organize your data in the database is a key factor in the design of most systems. Most systems have a database, and doing it well up front is important, not just in the initial implementation, but it has ramifications in terms of support. If you get the schema incorrect and have to update databases schemas in the field with software updates, it makes the problem a lot more difficult. So you want to try to get your database schema and the way you're going to organize your data well established early on in the project. Otherwise, you will pay a penalty. So just words of advice. So you might want to take your person that has the most experience with databases and make sure he has a clear schema for organizing your data and storing your data, and have it reviewed by the rest of the team. Not only for project teams have I seen that a problem, but I've seen that out in the workplace too. Is the data base schema hasn't been properly designed and reviewed, and hence you get problems. All right. Well, thank you. I wish you the best of luck for the Boomerang team. Yeah, you guys got a big project there, and you are working with the customers, so that adds, like I said, an extra level of complication. But I'm excited to see what you guys come up with.
Thank you.
So any other questions or comments regarding the class? That takes us to the end of our time.
I have some, but it's specific, so I'll wait until after.
Okay. All right. So I'm going to go ahead and stop the recording, but if you think of anything, feel free to chime in.